Welcome. Let's go through our 3D and similar solids study guide so that we can make sure we are as prepared as possible for this test. Beginning here, we have a cylinder, so find your surface area formula. Surface area then is going to be 2 pi r squared. That's going to give you the area of both bases, plus 2 pi rh. That's the lateral area for what we have on the sides. Plugging in those values then, 2 pi times a radius of 10, because we're not going to do the entire diameter of 20, just half of that for the radius. This is squared plus 2 pi, radius is 10 again, and the height is 8. Height is that distance from circle base to circle base. So you plug that stuff into your calculator, and we can give our answer in terms of pi, which would put us then at 360 pi. These are square centimeters. Or if we had multiplied that out to a decimal, we could be talking about 1,130.4 square centimeters. The volume for this figure then, volume for a cylinder is our pi r squared h, straight off the formula sheet. Again, using that radius of 10 that we identified as half the diameter, using my height of 8, you can give that answer in terms of pi, where you're doing 10 squared times 8. This is 800 pi, and it's volume, so those are cubic centimeters. Or multiply that out into a decimal, multiply by 3.14 in your calculations, 2,512 cubic centimeters there as well. Next up, we've got a rectangular prism. So when you want to find the surface area for that rectangular prism, we're thinking 2LW plus 2LH plus 2WH. So identify what you want to be the length, the width, and the height in that item so that you can be consistent throughout your plugins. So 2 times 4 times 20 plus 2 times 4 times 8 plus 2 times 20 times 8. Plug all that in. And now straight to your calculator with it. We're talking about 544. This is surface area, so these are square inches. Then we can go ahead to number 4, where we're asked to find the volume for it. Volume of that rectangular prism, LWH, length times width times height. So with a length of 4 and a width of 20 and a height of 8, my volume then is 640 cubic inches. Moving on down below, we have a cone. So to find the surface area of the cone, we're going to use pi r squared, that's the area of my circle base, plus pi rl to get the lateral area of that incorporated. So this is pi times the radius squared. Radius is given as a 2.5. Plus pi times the radius of 2.5 again, and then times the slant height. Slant height is identified for us along that edge, so this is 5. Go ahead then, we can plug that in. To do this in terms of pi, multiply our 2.5 squared, and then add on the 2.5 times 5. That's everything that you have in the formula except for the pi. This is looking at 18.75 pi square meters. Or if you prefer to have that as a decimal, if you had multiplied it out, 58 point, we'll say 88 if we round to the nearest hundredths, square meters there. So 2 versions of that answer format. Now for the cone, the volume of our cone is the 1/3 pi r squared h. So we're doing 1/3 times pi times a radius of 2.5, that's squared, and then times this height of 3, right? Because your height goes from the peak directly to the center of your circle. So 1/3 times our 2.5 squared times that height of 3 gives us then 6.25 pi. This is volume, so these are going to be cubic meters. Or if you wanted that as the decimal, you'd be talking about 19.63 cubic meters. We are well on our way then with these calculations. So next up, in 7 and 8, we're looking at a pyramid. So thinking back here, surface area of a pyramid, that's going to be 1/2 LP plus big B. So 1/2 times the L for slant height. Slant height is given to us here then as 6.3. That's what we have from the peak along the slope. And then times the perimeter. So I got to find the perimeter of this figure. It has a square base. So 4 sides, all of them measuring 4 inches. That's going to give me a perimeter of 16 to plug in. Then plus the big B. So we got to find the area of our square. So that's going to be a side length of 4 times a side length of 4, as that length times width happens to be 16 as well there. That is purely a coincidence for us. So 1/2 times 6.3 times 16 plus 16 then is giving us a surface area of 66.4 square inches. And when you go to find the volume of that cone, we're thinking about 1/3 big B times H. So 1/3 times the big B that we just found, that's 16, and then times the H. We're going to need to calculate that height from the peak straight down to the center is the height that I need to know, and it forms the right triangle with the radius of sorts that you have from the square. So when the side length is 4, the radius that we're thinking about is just 2 from the center over to the edge, and then our slant height is the 6.3. So we're going to Pythagorean theorem to get that. H squared plus 2 squared equals the 6.3 squared. So the height then 5.97 for us to plug in. Now we can go ahead and multiply to get that volume of ours. This has a volume then of 31.84 cubic inches. Next item for us is going to be the sphere. The surface area of the sphere, that's 4 pi r squared. So 4 times pi times a radius that's given to us as 6. So you can call that 144 pi square meters for your surface area. Or maybe you want that as a decimal. The other option is to call this 452.16 square meters. Now, when you go to calculate the volume of that sphere, your formula is 4/3 pi r to the 3rd power. So my radius of 6 now to the 3rd power. This is going to have more with it. So we're doing 4/3 times 6 that's raised to the 3rd. That's given us 288 pi. And these are going to be cubic meters. Convert that also, instead of in terms of pi, if you wanted it as a decimal, that's looking like 904.32 cubic meters as our 2 answer options. We are looking at this hexagonal pyramid. So, to find the surface area now, surface area of any pyramid is 1/2 LP plus big B. So 1/2 times the slant height, that slant height is labeled for us as 21, and then times the perimeter. So our perimeter is the 6 sides that all have a length of 11, putting us at 66. and then plus big B. So big B is the area of the base. So we're going to be talking about the area of the hexagon. So when you look that up on your formula sheet, the area for a hexagon is 1/2 PA, where P is the perimeter. We just found that, 66. And A is the apothem, and that is your radius of sorts from the center to the edge. Not from the center to a corner, but from the center to a perpendicular side. That is 9.5 for us. So the area of the base on this comes out as 313.5. That's what we're going to use in our formula. Put it all together. Surface area of 1006.5 square meters. Also now, for the number 12, we're looking at volume. So volume of that pyramid, again here, this is going to be 1/3 big B times H. So 1/3 times that base. We just found the base, 313.5 as the area of the hexagon. And then times the height. We're going to have to do a little bit of work for that. Remember that our height comes down from the peak straight to the center. And then it uses the radius. In this case, it's the apothem is what the fancy name for it is. That's going to be 9.5. And we already know the slant height as 21. So h squared plus 9.5 squared equals 21 squared. Go ahead and solve that Pythagorean theorem problem. We are talking about a height of 18.73. Now, with this calculation, we can put that right on into our calculator. And so 1/3 times 313.5 times 18.73, 1,957.29. This is volume, so these are cubic meters. All right, so those are lots of our basic calculations to go through on these. Now, as we move on to the next page, what is the surface area of the composite 3D figure? So we have to do some work here finagling these different pieces together. So we are going to start out. I want to find the area of the triangular faces of this pyramid. And since it's a rectangular base, the triangles are going to have different areas. So I'm going to do the area of the front triangle, which will also then match the area of the back triangle. Area of a triangle is 1/2 base times height. So 1/2 times my base measurement here across the surface is going to be the 14, and then times the height of it. So I've got to know what the slant height is for that triangle. So this will be working then. I've got my height of 12 squared plus my pretend radius there as I go from that center to the front edge. It's not going to be all of 5. It's going to be half of that, 2.5 squared, and then that will equal the slant height for it. So 12 squared plus 2.5 squared plus this slant height to be 12.26. That's what will be the height in our front triangle. So we're talking about 85.82. Then I need to find the area of the right triangle, which is also then going to be the same as the left triangle. So this is, again, area of a triangle, 1/2 base times height. the base of it is my 5 that I have across the bottom. The height of it is happening to be the slant height of the pyramid. That's our 15. So the area of this triangle, 37.5. Now, I'm going to go ahead and find the surface area for my rectangular prism. So surface area is 2LW plus 2LH plus 2WH. So 2 times 14 times 5 plus 2 times 14 times 6 plus 2 times 5 times 6. And do that calculation. Coming out with 368. But I hope that you realized in this process that was also going to be giving us the top of this rectangle. Surface area includes all 6 sides. I do not need this rectangle top. It's already incorporated in there. So then the area for the top of my rectangle, I've got to figure that out. This is length times width on a rectangle. So it's 14 times 5 gives me an area of 70. So to put all of this together then for my total surface area, we're going to have to do 2 times that 85.82 because I need the front and the back area, plus 2 times the 37.5 area because I need the left and the right triangle panel, plus the 368 from the rectangular prism, but minus the 70 that we don't need for that overlap in there. Altogether, we're talking about 544.64 square inches of surface area for it. So surface area can be pretty challenging. You got to make sure that you really visualize all the pieces for it. Now, 14 then wants us to go ahead with the volume of the composite figure. So to find the volume for this, I'm going to need to do the volume of the hemisphere that we have on top. So that's going to be the volume of a sphere, 4/3 pi r to the third gets divided by 2. So 4/3 pi times a radius of 5.5, because my radius for the bottom is going to be the same as the radius for the top. And that doesn't even matter if it's going horizontally or vertically or at some angle, still the same. So put that into our calculators. So over all the volume, I've got 696.56 for the numerator, but then I'm going to divide it by 2 to get it for the hemisphere. You're talking 348.28 cubic meters. Then I'm going to have to find the volume of the cylinder. So that's 2 pi... Oh no, excuse me, pi r squared h. Sorry, I'm reading the wrong line. Volume of a cylinder, pi r squared h. So pi times my radius of 5.5 squared times that height of 9, right? Height is going to be how far from circle base to circle base. So 3.14 times 5.5 squared times 9, looking at 854.87 cubic meters. So then to find the total volume, we're going to add them together, the 348.28 from the hemisphere plus the 854.87 from the cylinder. $1,203.15 cubic meters for my total volume. The last question on this page here, what is the volume for this 3D figure when the center cylinder is removed? Okay, so what we want to do then, find the volume of the whole thing. So the volume of that cylinder, pi r squared h. So my radius on the whole thing, I can see across the top we have an entire diameter of 16, which means that then the radius is 8. Square that times the height of 24. So 8 squared times 24 puts us at 1536 pi. Then find the volume of the inner tube, where that is. Again, this is the pi r squared h. So we got to figure out what the radius is for that inner portion. The inner section has a diameter of 6, means that my radius is 3. So we're doing pi 3 squared times, the height is again still 24. You're looking at 216 pi cubic yards. So then the volume without the center is going to be our 1536 pi minus our 216 pi. You're getting 1,320 pi cubic yards of volume here. So this 16 continues us on. What's the diameter of a cylinder? If your volume is 539 pi cubic inches and it has a height of 11 inches. So talking about a cylinder with a volume. So let's see then. Volume of a cylinder is pi r squared h. Fill in what we know. If volume is 539 pi and I have a height of 11, the only variable left here is radius. Go ahead and solve for the radius. I'm going to divide by 11 pi. That'll cancel 11 and cancel pi. What I do to one side, I have to do to the other side. So divide by 11 pi again. Pi cancels pi. 539 divided by 11 is 49. So if 49 is equal to r squared, r is equal to 7 when we take the square root on both sides. So we continue on there to find now the diameter of this. Well, diameter is going to be 2 times r, so we're doing 2 times 7. Diameter is 14 inches. And so our number 17 then, what's the height of the pyramid for us? So remember that your height and your slant height make a right triangle along with that halfway point, the apothem, or the one that you're thinking of kind of as the radius. So to find that height, let's see, height squared plus the apothem. It's not all of the 12, just halfway of it. That's the 6 squared equals then my slant height 10 squared. You're talking h squared equals 64, so the height must be 8 inches when you take the square root on both sides. Next up there, you're going to be taking your cylinder water jug on a camping trip. The jug is 10 inches in diameter and 12 inches tall, so how much water will it hold if filled halfway? So this is the part that filled halfway that sneaks in right there at the end of the question for you. That's usually what gets students a little bit confused or has them tripping up there. So start out then, we're going to do the volume of the cylinder, pi r squared h, and plug in radius then. I've got a 10-inch diameter, which means that my radius then is 5. So we're going to do 5 squared times the height, 12 inches tall. So total volume then is 300 pi cubic inches. But like I said, we're only filling it halfway. I don't know why we're filling it halfway, but that's what the question asks us to think about. So I want half of the volume. So we're going to do half of the 300 pi. This is putting us at 150 pi cubic inches. Now 19 then, Jonathan makes a container to hold his belongings at work. It's a rectangular prism of 18 inches by 24 inches by 6 inches. And we're going to assume that 6 inches here is the height of it. He doesn't put a lid on it, so how much cardboard does he need to make this container? So we need to go ahead and find the surface area of this rectangular prism. 2LW plus 2LH plus 2WH. So 2 times a length of 18 and a width of 24 plus 2 times a length of 18 and a height of 6 plus 2 times a width of 24 and a height of 6. Total surface area then is 1,368 square inches. But we're not putting a lid on it. So let's find out how much is the area of the lid. That's the area of the top of this rectangle. That's going to be the length of 18 and the width of 24. So the area of my top lid is 432 square inches. So total surface area that is needed in this case, 1368 minus 432, that is 936 square inches. All right, some more of these scale factors and dimension questions then. What is the scale factor from A to B? From A to B, it's going to be 5 to 20. But then, of course, we are going to simplify. They both have a common factor of 5. Divide that out. We're talking about a scale factor then of 1 to 4, saying that it's 4 that you can multiply by to get from figure A to figure B. The perimeter ratio then from B to A. So I got to find the perimeter of B compared to the perimeter of A. Well, that's going to be a little bit difficult because it only gives me one side length. I don't know what the other part of this rectangle is. Hopefully it has clicked into you, though, that perimeter ratio is the same as the similarity ratio. Okay. So if I know what my similarity ratio is from B to A, that's the backwards from A to B, 4 to 1, perimeter ratio then is going to be the same, 4 to 1. 22, what's the area ratio from A to B? Area says we're going to square it. 1 squared is 1, 4 squared is 16. So 23 down here at the bottom of the page then wants us to know what's the area of the smaller figure if the similarity ratio here is 2 to 7. Okay, similarity ratio, that's one dimension, 2 to 7. Got to find the area. So area is then going to be 2 dimensions for us. Square each of these. That's 4 to 49. Use that to set up our proportion. This ratio has to be the first chunk that I use. I know the area of my larger figure, 25.6. That's going on the bottom because 49 is the bigger number. I got to find the smaller. So my unknown has to be on the top level with my smaller value 4. And then we cross multiply. So I am talking about an area of 2.09 square inches. Not much to it in that case. Turning over here on 24, the area ratio between two similar cubes is 128 to 162. So area has 2 dimensions, ratio is 128 to 162. Notice that these are both even numbers. I can simplify this fraction. It is the same as 64 to 81. I'm asked to find out about the volume. Volume is going to have 3 dimensions. We know that we have to figure out 1 dimension in the process. Square root of 64 is 8. Square root of 81 is 9. That's 1 dimension. Now to take that to 3 dimensions, 8 to the 3rd power is 512. 9 to the 3rd power is going to have us looking at 729, even better. So we use this volume ratio now to help us set up our proportion. That ratio needs to be the first thing that we lay in. And the volume of the smaller cube is 216. The smaller is 216. 512 is the smaller number, so that gets what we want. And let's go ahead and find the volume of the larger. Cross multiply here. We are talking about a new volume of, or I shouldn't say a new volume, but the larger cube has that volume 307.55 cubic centimeters. In 25, we are looking at that the height and the radius of a cylinder are multiplied by 2. What does this do to area? So on the area, that multiplied by 2 comes out squared. So we're talking about something that is going to be 4 times larger. Then part B says, what impact does this have on the volume? So multiplied by 2, but volume then gets it to the third power. You're looking at something that's 8 times larger. Now C follows it up. What if just the height was multiplied by 2, but the radius stayed the same? Would those results change? Absolutely, they would change. The figures are no longer similar. If only one dimension is affected, then you don't have similar figures anymore. And so you can figure out exactly how close or how different they are. Right? For example, if we look at the volume of a cylinder, pi r squared h, on my original figure, maybe I have a radius of 1 and a height of 1. So volume as pi times 1 squared times 1. Volume of that cylinder would start as 1 pi. On the new figure, my radius is staying the same at 1, but my height gets multiplied by 2. So I'm talking about pi times 1 squared times 2. So that's 2 pi. Comparing these two, for instance, the volume is 2 times larger. There would be a different comparison and a different result for surface area as well there. Last one for us then. The volume ratio of two cones is 2,662 to 128. Volume 2662 to 128. And I do notice that these are both even numbers, so I'm thinking I can probably divide, can probably simplify a little bit, 1,331 compared to 64. I want the ratio of their lateral area. Lateral area, any kind of area, has 2 dimensions compared to the volume that we started with at 3. So we got to bypass 1. So what is the cube root then of 1331? That's 11. The cube root of 64 is 4. Square these, so you're talking about 121 compared to 16. That's the ratio of the lateral areas. I hope that your 3D formulas and your similar solids are a lot more comfortable and confident for you now. Best of luck on your test.